All right, well, good afternoon, everybody. I'm Liz Martinez, and I hope you've had a really, really great morning. I have. It's just been fun. I've learned so many great things from the people that I've had a chance to meet today. So please know how much I appreciate you being here. I will tell you, as a parent, as a taxpayer, and educator, you are amazing, and I really, really, really appreciate everything that you do. So thanks. All right, so today we're going to take a little trip to Yellowstone. And not sure, has anybody been to Yellowstone yet? Ever? All right, all right. But again, please feel free. Yes, yes, Debbie. Fabulous, isn't it? It's just surreal, bizarre, and just draws me in like crazy. But feel free to turn your camera on if you wish. You can unmute yourself. This session is for you today. So yeah, we really do. And if you need traveling companions, I think Debbie and I are available to go. So, all right, we're going to do this. Make sure the sound is on. And we'll share. And we'll look at here. And my computer's been a smidgen wonky today. Oh, very nice, Joe. Remember much of it? Are you able to see the Yellowstone screen? All right, perfect, perfect, perfect. Thank you, thank you. All righty, so we're going to take a trip to a place that, oh yeah, yes, I'm sure it looked really, really like another world than Jill. You're seeing Jill's comments. They were just chit-chatting because she had seen it as a younger child, and then uh, after the fires. Debbie, that's okay. You need to have something to eat. We'll be good. All right, so here's what I was hoping we could do today is take a look at Yellowstone from maybe a different lens. And I have my timer set because I could talk about this park, and I am a geology nerd forever. So just tell me, Liz, be quiet. So we're going to take a look at the life forms. I mean, our students are usually used to, when they think of, I think, Yellowstone and some of the parks out west, national parks, they tend to think of things like buffalo, the reintroduction of the wolves, caribou, moose, things that we just don't have in the Midwest. So we're going to take a look, though, at a little bit different life form, therefore the microbiology. We are going to definitely take a look at the geological features because you just can't pass that up. We're going to take a bit of a look at human impact and some possible ways that we can connect NGSS to this. So again, please holler with any questions that you have along the way. All right, so this is just kind of a little collage. Not to necessarily spend a lot of time here, but this guy right here, right? Grant, 1872, founded the park as far as a national park. And not so much now, but originally having national parks set aside by the government was a pretty unique thing to the states there. And we can see that it takes up a lot of area. But you have it mainly in Wyoming, spilling out into Idaho and Montana, which I don't know about you, but a lot of students I worked with having a map of the states and now having used Google Maps and things so much, not necessarily aware where things are geographically speaking. So, right, there's the sign, obviously. On the right, you can see that there have been a lot of indigenous people that have lived in Yellowstone throughout the years, many, many different tribes. Down on the right-hand side, we'll kind of go clockwise here. There's a crinoid fossil, which, as you know, is one of the oldest in the world, and it shows that there was evidence of seas being there at one time. Perhaps the best known thing about Yellowstone, or the biggest feature, is Old Faithful. And then down on the bottom left, the picture is there because it used to also be a military installment, and what they ended up dealing with a lot was poaching. So that's where that graphic comes from. So it has kind of a rich, rich history. Yellowstone, the hot springs, geysers, and the Grand Canyon. Yes, there's a Grand Canyon in Yellowstone. They have a lot of unique animals, but there are more hot springs and geysers in Yellowstone than the rest of the world. And 50% of the world's hydrothermal vents, and we'll talk about the life that allows to grow, exist here in Yellowstone. So again, very, very unique. A lot of not only people from the US visiting every year, but it's a big destination internationally. So here we go. Get that mouse down there. All right, so again, these are kind of traditional exposures. Good, Debbie. Hope lunch was good or you grabbed something. That was wonderful. But you can see, again, these are some of the things traditionally that students think of, even adults, when they think of Yellowstone. And you're not wrong. All these are fabulous. So we're going to take a little look at some of these things. And you might be glad that we don't have smell Zoom or whatever for when we get to the mud pots and that. So let's start out with something that is just, to me, super duper fascinating. And it is also playing a critical role in detecting COVID in people. So as the name suggests, we have organisms that are related to heat. I want to hear just some potential standards, PEs, that this whole topic that we delve into might fit along with us. So take a moment. I'm not going to read these to you. These are actual headlines. Any thoughts, comments? Okay. Personally, I think my favorite one is cooking chickens in a hot spring. Not favorite that I happened, but just so unique as to grab your attention there. So one of the things that you could do is you could start out, if you wanted to, you could get these articles. Isn't it nuts? It's just crazy. And you could divide the students into groups if you wanted to. And this just might be a little a problem or a very small phenomenon that you could use with the students, and then eventually bring it back to where we're going to talk to. But let them delve into this, let them read it, and let them then think about, why might this be important? What impact, if any? And then go into where we're going to go now and come back to it. This also provides a really great opportunity for interdisciplinary teaching. And I don't know if you do that, if you're in a school that supports that or not. But it also, if we bring this into the science classroom, it helps students see that science is not siloed. You ever have your students draw a picture of a scientist? And think about the pictures that you've seen when kids have done this before. So it helps them to see that science is related elsewhere. So a little bit of information here that I'm not going to read to you, but take a look at these ranges of temperatures that these organisms live in. A little on the warm side, right? Even in the throes of winter, we would think that. So mostly we see this in archaea are able to survive, some different types of bacteria. And what is able to survive really depends on the water temperature. And so this statement right down here is, we obviously have proteins in our cell. And if those degenerate enough, then our cells won't be able to function correctly. And proteins are so critically important, not just a power bar, protein bar, some peanut butter, etc. But it helps in regulating our system. They help, when we found out that misfolded proteins can cause all sorts of illnesses, etc. But we're finding out more and more the importance of these things. So one of the things that you could talk about that the students may not have thought about before is, you could get into what's considered a growth curve. In order for these organisms, or any kind of organism, to survive, they have to obviously reproduce. So we have this lag phase where they're just getting started. So this just represents number of cells going up and time in general going off to the right. So with a lag phase, they're starting to grow, starting to multiply, because there is plenty of food, plenty of oxygen if they need it, right temperatures, right light conditions, etc. And then all of a sudden you can see this steep portion of this curve, right? That is where they're really, really thriving. Everything is really, really, really great. Lots of new neighbors, so to speak. with the life that's going on there. And then you'll notice that it kind of flattens out or plateaus and it starts to decline. And that is because in this area, the resources that are needed for life, it could be the food, it could be the clean environment because every living organism makes waste. It could be the temperature, the chemistry balance, etc. Not optimal, so therefore they will start to die off. Now in science and biotech, which we're going to talk a little bit about, we want to get things into this phase right here where they're growing really, really well. And it's an area you usually get into with your students. So we'll go ahead and move on. It is an area you could take your students to with life science a little bit different. Okay. So those organisms grow in something that's quite warm. You can see the thermal image on the left, and you can see an actual picture on the right-hand side here. And students tend to be fascinated with thermal images, and it's a great technology to use. So I would think they'd be engaged here. We can take a look at the thermal imaging. And in a minute, we'll take a look at another picture similar to the one on the right. But if you look at the bands of color on the right from the water out, and if you look at the bands of color in thermal imaging, there's a lot that we can tell. We can tell if temperature is changing, obviously. So if the temperature is changing, that can impact the life forms that are growing there. We also know if the temperature is changing, and it could rise or it could be falling, that might be an indicator of an area to watch for some type of activity, geological activity, because we're getting that pressure change when we get those temperature changes. So geothermal activity. Also too, we can take a look at the pH might be changing. So not only the heat, but that affects the pH. It is going to also affect what can be dissolved in that area. So all of that fits into these thermal pools and why they're so important. Right. Oh goodness, it's going to stick again. I think I need a new battery now. All right, so let's talk a moment about pH. How many of you do pH with your students? Time of the day, the after lunch flow. Okay, some a little bit. All right. So get this whole idea. We're trying to take a look at the ecosystem, excuse me, of Yellowstone and maybe look at it from some different perspectives than students oftentimes do. So we've talked a little bit, and we'll come back to it, about life forms. That's another way to look at microscopic life forms in a different setting perhaps than the students have engaged in before. We can look at pH, and we can look at pH not in that traditional, like move the item along the pH scale. It's really great, but here are a couple other ideas. These different geysers you can see, and then we have the mud pots, and this is a picture of a mud pot up on the right. That's why I said it's a good thing we don't have smell-o-zoom, because oh my gosh, rotten eggs deluxe. But you can see that these features have a wide range of pH. Okay? So you can get into the discussion of pH. You can get into the discussion that, you know, this is where we live, like in the pH world. But we have all these things that are living in these extreme pHs. What is going on there? Why can they do that? Why can't we do that? Okay. So a lot of the energy here comes from sulfide. Sulfide then is converted into sulfuric acid. A lot of students have heard about that and how dangerous and how smelly it is. What happens is this comes up through the rock. There's a lot of clay there in this area where these mud pots are at, and that's where you get the stinky sulfur smell, because bubbles obviously are made by gas that's brought up because of their density being lighter than the substance that they're in. And when those bubbles pop, whoo, you will definitely know it. And the pH again has a great impact on life. So we're going to try to cross our fingers here and hope that we're good. There we go, this website. I don't know how many of you have used the PhET simulations before or not. They're really, really great. One of the things like about this site that I really like, and again, there's nothing wrong with that traditional drag and drop one that people use oftentimes. I've used that forever. But you can go ahead and you can now mix different things together with water And you can see how that changes the acidity or the alkalinity of something. So let's think, a lot of teachers live off of coffee, right? So we can add coffee and you can see the level rising there. And then you can drag the pH meter and you can see this coffee is around 5. And students know that most water is pretty close to neutral. So we can add water, we can watch what happens to the pH, and you can see that it's getting closer to neutral. Now, one thing that's great about this simulation as well is that students oftentimes think, let's just drain this. Students oftentimes think that 1 drop of acid and 1 drop of base neutralize each other, and that's not the case. So with some of these items that they have, let's get something that's more acidic there. As it goes up along the right-hand side, you can see the amount is there. So that's our acid that we've dropped in. So we get the pH meter there, and whoa, it's a 1. I have nothing to do with that. So if we add the same amount of water, whoop, there we go. You'll notice that equal amounts of water, which is pretty neutral in this case, and an equal amount of acid do not get us to the center part or neutrality. So they can see that some acids are going to take more water, in this case what we're using, to neutralize them, and you can see we're going to be going on for quite a while here. So let's get back here. What are you seeing now, I guess is what I should ask. That'd be a better question. I want to make sure we got back to the right page. Somebody. Are you seeing the PhET simulation and not the pH simulation, right? Let me switch this page down here. Okay. What are you seeing now? Are you still seeing PhET or are we seeing color clues? All right, perfect. So, all right, so the other thing that we can do here with these thermophiles, pH, knowing what minerals are there, is we can take a look at, this is a pretty famous area called Morning Glory Pool is what most people call it. One of the most photographed places in the world as well. But if we were to take a look at these colors, you can kind of see a darker blue in the center. You can see more of a turquoise green here. You can see some yellow, and in some pictures you can start to see some orange, and then you get into these different browns. What they do is they show us that there are different chemicals present there. So since different chemicals are present there, the pH is going to change. It will also tell you, you can look at these colors and figure out roughly what the temperature is. And then you can figure out what type of thermophiles or this life might live there, what kind of photosynthesis is going on, because these things are really interesting, these thermophiles with the photosynthesis process, as well as what kind of light energy is needed. So by looking at all those clues then, I threw this together. So who cares about all that gobbledygook? Well, take a peek at some of the words. And these are all important because thermophiles help us do all of these things. So let's jump first of all to when I said this is really related to COVID and impacting us right now. You've probably heard that there are quick tests, right? And then there are PCR tests. Well, the PCR process was developed based off of these thermophiles. And thermophiles are used in this chain reaction, okay, the polymerase chain reaction. So it helps with that. So it helps in biotech. We've been able to develop a lot of medicines based on this. We've been able to do what they call bioprospecting. That's pretty much where we found something in nature. For example, sponges, their capability to ward off all sorts of bad stuff in their environment, because they're stationary, they have to have that ability. So we've taken that ability, we've taken some of the proteins from the sponges and been able to develop some very efficient cancer treatments. Okay. So the PCR and bioprospecting, we're doing all of that with these thermophiles. What else? There's some clothing that has been developed by these thermophiles. And I think one of the things that to me is really intriguing, I'll say two things, is knowing the age of different life forms on the earth. This is really helping us out much more accurately. We can identify things and their ages based on that. And then extraterrestrial, not meaning that ET is going to phone home or anything, but the fact that where can we find perhaps some other life in our solar system that we had not thought about before. Okay, so let me stop gabbing for a moment. Questions on thermophiles? Thoughts about it? Man? Yeah? Okay, all right. So it's just another way to meet some of the standards with something that, or PEs with something that's a little bit different than what they've experienced before. So when you see those beautiful heated pools, when you smell those stinky mud pots, when you see the water flying out of these geysers, you can think that there's a lot of other life that's really critical to our life here on Earth. Okay. So let's get to some parts that we tend to think of historically when we get to Yellowstone. Oh my gosh, the geology is it's just incredible. And we'll take a look, a couple of careers that can obviously come out of this. So teaching this in the class, one of the things that we can do, I'm not sure, does anybody else have to teach ELA along with your science or not? One of the things with Common Core state standards, and I know anytime we introduce a set of standards, we're always like, oh my gosh, here we go. This is good, but one more thing for me to do. But in the ELA standards, it talks about learning to read informational text and being able to interpret that. In science, we have so many different types of informational text. So my point of saying that is, for example, here's a map. Maps are types of informational text. So you're reinforcing what's going on in ELA, but also showing the students that science is not siloed. So these are different regions based on different paleontologists and the surveys that they've gone into. And we'll go into the difference between an archaeologist and a paleontologist in just a couple of minutes. Okay? And once again, if you take a look here, and we're looking at evidence for life and helping us to figure out what this evidence can be used for and why it can be used. Here's a crinoid fossil, which again is the oldest type of fossil that we have. And we can take a look at where we find it, like what level in the strata that we find it, its location to other ones, and so forth. Okay. Another thing that I used to do a lot was with plate boundaries, and we have so many different fault lines and subfault lines now than just the San Andreas. So we have like a really big one in Illinois, one of the biggest ones that changed the course of the Mississippi. And if that buddy goes, then we're going to be in trouble there. But I used to take, I don't know if you did this or not, but take like sandpaper or pieces of wood and let the students move them like side by side. We have divergent, convergent, and transform boundaries. But I like taking something like this. These are 3 different little illustrations based on data that's been found about the strata here. So what I've done before now is I've taken something like this and I've cut it along these dark lines here to make puzzle pieces. This could be another puzzle right here with 1, 2, 3, 4 pieces, etc. This one's kind of interesting when they get to these last 2 pieces. Like, wait a minute, I've never seen one that goes diagonally like that. Have them assemble the puzzle, so to speak, to put this back together, this illustration back together, and talk about why did they put the pieces where they did. Now, if they put them together like that, what does that mean potentially? There we go. Welcome, Ann. What does that mean as far as what can happen there, as far as the landforms that you're going to find? Okay? So And why is this part right here higher than this? And you could talk about, and students can predict what would happen all of a sudden if on the top one, the first section started to put some pressure here at the bottom. That second little piece might pop up, and that's going to change the terrain. Uh, and you can see above here, they have some fairly well-known, what do I say, features, such as the Yellowstone River. So you can see what's beneath these features, but those are up there for reference points. And there is a scale there as well. So just a different way to look at action within the Earth's crust and how that can impact what we see and what landforms that we find. Okay. So you'll be able to download this activity, Older Than Dirt. It could have been my name instead. But what it is, one of the things that students in middle school need to do is they need to be able to construct a geological record, right? Based on events, so to speak, a timeline. So we have these different eons and eras here. It's not important that they memorize these. What is important is that they see, wait a minute, there are these different numbers here. So this one, like really, really long time ago, that there's an order to it based on ages or the dates, right? That we are right here. A million years ago, or MYIA, I mean, might not be an abbreviation that they've seen very much before. So what they do here is there's a set of fossil cards, and they do copy in black and white really well. I never had a color copier to use in the schools that I was in, so they will do that. And once you have those copied, what you can do is take the fossils and let the students talk about them and think about, all right, where did this occur? Why might it have occurred here? But start to make some predictions once again. And what they're going to be doing then is they're going to, first of all, develop a scale now that they've taken a look at some of these fossils. And they're going to use this information here. What's not to love about toilet paper, right? Especially as a middle schooler, unrolling it down the hallway. So my suggestion is that, and I know this sounds funny, a 500 sheet roll of toilet paper is the best. Cheaper, the better. Or you could use adding machine tape. But the reason I like the toilet paper is the students aren't taking the tedious step of having to mark off the same distance every time. Those tear lines are there for them. So what they will do then is map out a timeline with all these eras and eons in there. And then they will take those fossils and they will try to put them in the correct spot and be able to figure out or explain, justify why put those fossils there. For example, something underwater could be some of the oldest fossils because we know that that sea life had occurred back then. There's also a PowerPoint to help out with the rock strata. But anyway, that's just a very short, brief overview of that activity that you're welcome to download and use the information from. And again, if you use TP, 500 sheets is really good. All right, so that's one where we can look at, again, where the thermophiles helps us tell more about the origin of life, the age of life. Looking at fossils definitely helps us do that, and students are a bit more familiar with that. But one of the things that we kind of mentioned before was this idea of a couple careers. Okay, there was that a paleontology map that we took a look at, right? So I think, once again, students tend to think of like, I want to go explore about volcanoes. I want to be a volcanologist. Right? Which I would love to do. You look like a big baked potato in that outfit. But here are a couple different careers for archaeology and paleontology. And I'll be quiet for a minute while you take a look at the flow chart. We just throw in the chat box, please, what might be a purpose of sharing something like this with students? I want to see what your ideas are. Yep, I agree. Those are great comments so far. They're coming in really slowly. My internet is super slow today. Yeah, I think that connection of the concepts to the careers, yeah, the awareness. Yep, real world careers. Anything else that you can think of? Yep, exactly, exactly. Classification is so critical here. You know what, Terry, I like that comment because it's just been like so nebulous, even to myself. I can't imagine being a middle schooler and being able to figure out what that is. Oh, yeah, Jill, look at what Jill took. Yeah. You know, I think sometimes we don't stress enough with students that, yeah, it's good to find out what you're interested in, but it's also all right to figure out what you might not want to do. So you can see that. And that was one of the things I really, really liked about this flow chart here. So it comes from, let me get it correct here. There's a really great science center in Hemet, California, I believe. It's called Western Science Center. They gave me permission. This is taken from one of their displays. It has a lot of really interesting stuff and good resources for educators that you can download for free. Uh, they were the ones who gave me permission for this, but I just really like, kind of old school, new school. Nope. Yep. Um, and they have a simulated dig site right there. They had discovered, it was a mastodon right there, just a few yards away, when they were doing a another building project that dealt with the water reservoir. So they found a lot of great things that they unearthed. Okay. So we can take a look at some careers. We can take a look at fossils that they found because there have been a lot of interesting fossils found at Yellowstone. Um, and again, the location, where they are relative to each other, how many you find, what the current conditions are, so many things. And I don't know, I always thought it was interesting. Once I saw that sign there, if we go back to that flow chart a minute, the whole idea of moving off of the earth to look at uh, paleontology differently in a different place as well. So I don't know about you, but this is what I think most of our students tend to think about Yellowstone. It has a lot of earthquakes and volcanoes, and there's that super volcano, which there is. And when it goes, the whole world is going to go. There's like that doomsday type of thinking. But one of the things I will say here is that, yes, when that erupts, that volcano, it will have big time consequences and effects. Maps are really great things to do here. Simulations, there are several simulations that will take you and let you help the students find the epicenter. Um, and they're just really interested in that as well. Another thing too that students may not realize is that Illinois, because the fault line, has a lot of earthquakes. And they may be surprised that when they look at earthquake data from Yellowstone, how many earthquakes actually occur every single day. So logarithmic scale, does anybody have a good way to physically have an activity where students can really delve into maybe a model of a logarithmic scale, like with the magnitude? Because, a one doesn't look that much bigger than a zero. Okay? But I've been in like a 3.5 earthquake and a 3.7. If we look at that, most students look at that, that's only like a 2/10 difference, but oh my goodness, it's a huge difference. So if you have any ideas or any resources, I've been trying to figure out an activity for years of how to do this to scale without having to go like down the whole street or the whole block kind of thing. But back to earthquakes, they have the magnitude. There are a couple different scales for the magnitude that can be used. But there's this website that shows you, and you can see some of these are grouped right here. There are keys to it. So when geologists look at this and try to figure out, there might be an area of the park that's ready to erupt. They can take a look at what is going on, where they see the patterns of these earthquakes. You'll see down here in Salt Lake in that area, a lot of earthquakes through there because there's some fault area there. But again, looking at this, they can go to and take a look at the individual earthquakes. This was, okay, on January 14th has the earliest here. Through the 28th was when I took the screenshot of it. But they can take a look at lots of different ways to analyze it. They can manipulate the data through the control panel. You can really zoom in. There are different layers they can put on here. And it's just fascinating the data and the evidence they can find, we can all find from using a simulation like this. And again, they can use this to take a look at the impacts here, what the application might be to use in the predictions and the changes that go on. And does anybody have a shake table to use in their classroom? That's also kind of fun to do. All right, so we're just going to watch a tiny clip here. We're going to hope that comes through. Let me turn my sound up a bit. If you could just give me a thumbs up if you're able to hear.
Yellowstone's hot water features all point to one conclusion. Yellowstone.
Yes, okay, then we'll keep going. Thanks, Jacqueline. Well, maybe.
Must be powered by the heat of a volcano. Geysers only erupt if the rocks are hot enough to turn water into steam. Gases from underwater have the same composition as those from volcanoes. Quartz in the hot springs must have come from volcanic lava.
There is an immense amount of energy coming out of the ground that's expressed by the geysers, the mud pots, the hot springs, and the steam vents. Where's all that heat coming from? It's coming from the molten rock associated with the Yellowstone volcano.
Now, let's stop it right there for just a moment. I will say that I think one of the things that I might have been negligent on when I was teaching is that students knew that there was this molten stuff, there was this lava, there were these rocks that were starting to cool down, igneous rocks that were still warm. But I don't know that I always help them understand that idea of the relationship system and system models, if you will, between the idea that these rocks and that there's water underground that's being heated up. And with that heating of the water, obviously it's going to expand, there's going to be a phase change. But as that goes along, that there's pressure being built up. And as also that hot water and that pressure is coming through, it can take some of the minerals and dissolve it in that water. And then when something erupts, whether it's spectacular, like some of the geysers, Old Faithful, and some of the other ones, or whether it's something that's not quite as high, like those mud pots, or even the Yellowstone River, there are parts of the bank that are ice cold, and there are parts that are boiling, just bizarre within the same river. But pulling that all together, that, you know, that heat doesn't just make the rocks, it heats up that water, and there is that water underground there. So you might want to look away. I should have brought you Dramamine. Let's go back here now. To these initial headlines. And I think you can surmise what the articles would be about. Why would we even care about those things? How could they relate to Yellowstone as a park, as an area of multiple ecosystems? If you jot some ideas in the chat. Yep, very much so. I mean, the people who cook the chickens, if you think about the bacteria that are in the chicken, and not necessarily that they were bad chicken or anything, that bacteria is being introduced in there, and that can throw off the balance, the pH balance, just introducing a new species, etc. And even though we're not seeing fish in this hot spring, we're not seeing visible life, it can definitely damage that as far as ecosystem. Anything else that you can think of? We're going to do this.